Good morning, grade 10. So today we are talking all about applications, which really means word problems. Still SOHCAHTOA, still trigonometry, but we're just setting them up a little bit differently because we're going to use information given in the question. Now, recall from last class, the acronym that we used to remember our trigonometric ratios is SOHCAHTOA, where this gives us our ratios between all of the different side lengths. Now recall again that trig only applies to right triangles. So these simple trig ratios only apply if there's a 90-degree angle somewhere. Trig ratios, we always use them to find either the side length from last class or angles within a triangle. That's our goal. Now, if we do see a question today that says solve a triangle, we need to solve for all unknowns. So this is all unknown side lengths and all angles. So essentially, tell me everything you don't know. Now, for those of you that like step-by-step procedures, we're going to kind of go with a four-step system for solving word problems. First thing you do, and the most important, is to read the question carefully. So that's looking for keywords. What is this terminology? What is it telling me? Second thing you want to do is draw a diagram. Once you have your diagram set up, I want you to be thinking, what is unknown? What am I solving for? Step number 3, please make sure you have your let statements. Let x represent yada yada. And the last one, set up the ratio and solve. Now here's a little bit of terminology. So if that is something you struggle with, this is where you want to pay particular attention. An angle of elevation is an angle from the horizontal up. Okay, so notice that's the horizontal up versus an angle of depression is from the horizontal but down. So it's just the directionality that's changing. Notice that both of these angles are kind of within that Z pattern, but making sure we're drawing our diagrams perfectly. Now there's also some other terminology. You might consider this to be a vertical rise, horizontal distance, length of a ramp, and the angle of the ramp on the inside. So those are things we'll see in the last question. Let's try our first one out here. Find the angle of elevation if you are standing 400 feet away from a building and the building is 450 feet tall. So I can see the first thing I've done is actually there's already a diagram. So this is that angle I'm looking for, that angle of elevation. Because in this diagram, angle X is already given and labeled, I don't have to have a let statement. From here, I know the opposite angle and adjacent angle. So using my acronym, I said I have opposite, I have adjacent, so I want to set up a tangent ratio. So tangent of X is opposite, 850 over adjacent, 400, and we know to get the inverse, I'll do this in 2 steps. I do the inverse tangent, and I get 64.8 for X. Please make sure you do a summary statement, therefore the angle. And I'll say is approximately 65 degrees. I'll try to include in these questions if I would like you to round to the nearest degree or things like that. Generally, the nearest degree is what we look for. Beautiful. Let's try a few more. Here is one that does not have a picture already. So from the top of a tower, first thing I'll do is I'll draw in my tower. Okay, these are all the apartment building windows. From the top of the tower, the angle of depression to a stake in the ground. Well, a stake is just like a word for a peg. There's a little peg in the ground. The angle of depression from the horizontal down to the stake, that angle of depression, it says, is 60 degrees. The top of the tower is 80 feet above the ground, so this whole side length is 80 of this triangle. And it wants to know how far away is that stake. Something that's important in this diagram to include is that we're assuming this building is at 90 degrees. We need to have that angle in there. Because also the horizontal, I know this whole thing should add to 90, so this part is an angle of 30 degrees. Let x represent the distance from the building to the stake in the ground. And we set up a ratio from that angle. I want opposite, and I have adjacent. Opposite, adjacent, again, I'm setting up a tan ratio. No h. So the tangent of 30 is my opposite, x over adjacent, 80. Multiply 80 times the tangent of 30, and we get 46.2. Therefore, the stake is 46.2 feet from the building. Okay. A few more to try out. At this point, if you want to pause the video and try some more on your own, please feel free, but I'll continue here. A ladder is leaning against a house and makes an angle of 30 degrees with the ground. So that's this angle here. The foot of the ladder is 7 feet away from the foot of the house, so that's this distance. And it wants to know how long is this. I'll label it h for hypotenuse. Let h represent the length of the ladder. Again, from the angle 30, I have adjacent, and I want hypotenuse. So, toa. Again, have adjacent, want hypotenuse. I'm going to use cosine. Cosine of 30 degrees is equal to adjacent, 7 over h. Cos of 30. And I get this to be 8.1. Therefore, the ladder, 8.1 feet long. Okay. Try again. A tree casts a shadow, so here's my tree. Beautiful. And the shadow is 21 meters long. So if I'm looking at this, this is 21 meters. We're assuming my tree is straight. The angle of elevation to the sun is 51 degrees. So if I'm considering, let's just think the sun is over here. Actually, it doesn't really matter where the sun is. Let's put the sun up here. It's a very big sun. We'll make it smaller because it looks ridiculous. There's the sun. The angle of elevation from the ground to the sun is going to be 51 degrees. What is the height of the tree? Let h represent height of the tree. I have adjacent, want opposite, we use tangent. Tangent of 51, opposite h over 21. And I get h to be 25.93. Therefore, the tree is 25.93 feet. Oh, meters. That's a tall tree. Meters tall. It's a giant tree. Right. So at this point right now, you should feel about a 5 out of 5 on the wellness scale. If you don't feel as comfortable with this, Please make sure you go back and review this, or maybe try some IXL practice. We're going to do 3 more examples, and these 3 examples are a little more challenging. So these are harder. The Uniform Federal Accessibility Standards specify that the ramp angle used for a wheelchair ramp must be less than or equal to 4.78. So what they're trying to determine right now, they're saying this angle of the ramp has to be less than or equal to 4.79. Now you'll notice what I've drawn is a little theta. It's just an angle measurement. In one particular situation, they're saying the length of one of the ramps is 16 feet. That's the ramp itself. So that's that top measurement. The vertical rise is 2 feet. Calculate the ramp's horizontal distance and the angle. The second part doesn't meet the standards. So we're going to solve for 2 different things. We're going to be solving for x, and we're going to be solving for theta. Let theta and let x represent. Okay, so I'm just being a little bit lazy here with those let statements, but please make sure they're included. First thing I want to do is solve for my theta. I have opposite and I have adjacent. Tangent of theta is 2 over 16. Do the inverse tangent. Opposite over adjacent. Sorry, that's not tangent. Opposite over hypotenuse is sine. Sine of theta, opposite over hypotenuse, inverse sine, and it gets me 7.2 degrees. Right now, does that match with the accessibility standards, less than or equal to 4.78? No, it's too big. It doesn't meet the standards. Remember, it also wanted to know the x value. There are 2 ways to do that. I can either set up Pythag. X squared plus 2 squared is equal to 16 squared. Or I could have used a ratio, a tangent ratio. Either way, you'll get the same solution. So it doesn't matter which approach you take. 16 squared minus 4 is 252, which gives me x to be 15.87 feet for the second part. 2 more questions to go. We're going to go a little bit faster. Please pause to make sure you have everything written down. I want to build a ramp vertical rise of 6 inches. Okay, half a foot. So half a foot, 6 inches, whatever. I want to minimize this horizontal distance taken up by the ramp, but still meet the standards. So draw a ramp showing the approximate. Well, for it to meet the standards, this has to be 4.78. For that to occur, opposite over hypotenuse, opposite over adjacent, is tangent. Tangent of 4.78 equals 1/2 over x. Cross multiply, and x becomes 5.97. That is the biggest distance, and remember this is in feet in order to minimize. Last one, you heard the bell there. Hot air balloon, 600 feet above the ground. How far is she from the point below the hot air balloon? If that's 20, that makes this angle in here 70 degrees, and I can set up a ratio. Tangent of 70 equals x over 600. X equals 1648.48. Please make sure let x represent the distance between her and there. And that's it. Please move on to your homework when you're free, and I will see you guys next week.